Here's a really cool use for an oscilloscope in vehicle repairs. So essentially, just a quick backstory, the horn has like intermittent connection. It's like, it's not a nice solid buzz, right? So the first thing I do is I go, oh, okay, this is what they call the clock spring, or it's a communicator. It allows electrical connection through a column when the wheel's moving, right? It's like a electrical wiper. Those of you guys that have seen this know what this is. So this is actually not a clock spring, it's just a wiper in here. It looks like a clock spring, and it could have a clock spring. But anyway, I go to replace this, and I'm like, okay, well, that's one side of the communication, okay, because you need to go to the horn button and then back through your wiring. So this is a one-wire communicator, but to make a horn run, you need to pass power through. So I'm like, okay, that's fine. Where's the ground? So you have one for the positive, right? But where's the ground communication? Well, the ground communication is through the column itself, the center shaft. And I'm like, wait a minute, that's impossible, because the column is not attached to the vehicle. The column is, but the center shaft is not attached to the vehicle. It's separated by bearings, by universal joints, because it moves, right? So anything that moves can, by theory, not be attached to something. So that's why you have wipers here, because the wheel moves. It's theoretically not attached to the truck or the column. It's a moving object. So you need to communicate that electricity through. So then I'm like, okay, so you're asking me to go through the shaft of the column. Where is the wiper for that? Well, there is none. They're asking it for it to get communication electrically through the bearings, through the universal joints, through the steering box, wherever, right? So I'm like, okay, let me do a simple test here to just confirm that the ground is shit. So here we go. What I'm doing is I'm using a good chassis ground through my oscilloscope, and I'm using it as a voltmeter now, essentially. We're looking at the time base. The time is divvied up to, what do I got here? 100 milliseconds per division, right? So 10 of these things would be 1 second, I believe. So it's kind of like a beating line going across. And my divisions are 1 volt. So if I see a problem, you can't see the little boxes in here. They're really hard to see. There they are. Okay, so each time it jumps one of those boxes, it's going to be 1 volt. And I got it just off a center line here. But here we go. The oscilloscope's just reading. No change. So if you know what a voltage drop test is using a voltmeter across a circuit, and if there is no voltage drop or there's no bad connections, you will not see the voltage meter rise, because there's no voltage potential across it. It's 12 volts on one side, 12 volts on the other. But anytime you have a break in that, you're now seeing the differential, and you'll read that as a differential in volts. So right here, as I sit, I'm going to go ahead. I'm actually put a load on the horn. I put a 8 ohm load, so you're not going to hear the horn go off. But basically, I could connect and reconnect this. I'm now making the connection as if I'm pushing the horn. And you see a little jump? The little jump is just loss. That's like loss through the wiring. So there is a voltage drop difference here, right? And if I'm to read this, let me see if I can read this. All right, there we go. So it is a voltage drop of 120 millivolts. I'm seeing the jumping here at the bottom scale. I'm trying to get you a read on this. So yeah, you see these little jumps as I hit it? But that's not technically a bad connection. That's just showing you, hey, the wiring's semi-inferior. Well, no wiring is perfect. It's always going to have loss, so you're going to read that. So there's your loss, right? It's at 120 millivolts, peak to peak. All right, now watch this. As I move the column, you'll see these spikes. And now if I put real good pressure on it, it gets all funky. And that's because that's telling you that the ground through the column to the chassis is not good. So that's a visual indication of bad connections in real time. Yeah, see, I can wiggle this and I can get all kinds of funky. Right, so that's a use for an oscilloscope. It's basically just showing you voltage over time. So don't ever think an oscilloscope is like some tricky wizardry. It's not. It's just a voltmeter showing you differences on a time scale. So very cool. And yeah, this little tiny one, if anybody's ever interested, these are just as a Fernersi 2C53T. They make a different one, but a cheaper one. This is only like $100. So you know, it's also a voltmeter and all the other shit that you would want with something, but real cheap Chinese thing, but works great. So there you go. So there, in this case, unless I find a communicator somewhere in the column system that's going to communicate the shaft to the chassis at a 0 ohm connection, there is no way to fix this. There's no way. There's nothing I can do here. You know, so the customer, you just have to tell them, yeah, you have an intermittent, shitty sounding horn because there's no communication. You don't have a well-built circuit right from the factory. So could I install some sort of a brass connection wiper, you know, with a ground lead hooking onto the column? Yeah, I mean, the column has so many wraps to it, so I'd never be able to do it with a wire. It has to be some sort of a sliding contact. So there you go. There's a use for oscilloscope. Any questions, comments? Leave them below. Thanks.